Wouldn't it be great if you had a solid, sturdy workbench, but with a single quick foot press, it's up on 4 wheels and mobile, and then with another single quick foot press, it's down solid again? And wouldn't it be awesome if that worked for anything else too? Especially for small workshops like my old one, or if the space has to be flexible and shared with a car. In this video, I want to try making that. Retracting wheels that are actually good and quick. If I would have known how many ups and downs this project had prepared for me, it works. But I am a bit concerned about this flex. This time, it should work. That's now working reliably. Now the bad news, and there are quite a few. That's cool. Oh no. I have to remake every single part. I might have changed my mind, but the idea was so simple. We have wheels mounted to the bottom doing nothing, but when needed, quickly lift everything up. Eventually. That's no new idea. These retracting wheels have existed for a long time, are cheap and easy to install. Unfortunately, they suck at being quick and user-friendly. They stick out a lot and can't be used on cabinets that don't have full access all around. You must be able to reach every caster. Basically, freestanding. But once against a wall, it gets annoying and terrible in a corner. I have to either crawl in there and release it by hand, dangerous for the fingers because releasing is not gentle, or use a stick. That's okay for this CNC router that I move once a year or less, fine. But for anything that you might move daily to make room in a garage for a car, that's a pain. This is what I would call quick, user-friendly retracting wheels. The ones I built last time for my Vice. Quick up and quick down. Can you see the difference? It's so quick and simple, I don't have to care about the time it takes to move to the best location for some task. I just do it. And although it now isn't nearly as solid as bolted to a heavy bench, it's the flexibility that makes it so useful for so many cases. Once I had the wheels working for the first time on the Vice, I knew I wanted more. So now starting with the workbench, and I don't even know if I need it here, but I also didn't know I would enjoy it so much on the Vice. So let's go. This clicky mechanism is key for everything. That's what makes it user-friendly and quick. Basically a pen mechanism on steroids to handle weight, which I developed in my last video about the Vice stand. But it still has some minor flaws and needs part to be adjustable. So for the workbench, everything will be integrated into one assembly with a leveling foot that can simply be screwed to the workbench leg. All parts need to be metal, of course, and I designed them to be cut from the same material thickness in one go. From my last video, you know that xTool gave me this laser system to integrate in some videos, so I will continue using it for actual projects. Parts are off the laser, quite a bit going on, but everything needs deburring before moving on. I've already learned that tabs are great. Sweet, that will make the welding simple, but a couple more steps are necessary before that. Most holes are for bolts, which I cut undersized to now enlarge. Straight from the laser, it's just not good enough. And some holes, like the one for the clicker, need to be very precise, so they get reamed. And a short piece of rod for it to rotate on. Let's test the mechanism. It works. The wheel mounts about here, and like this, it will be up, then foot press, workbench is up, snapped in place, foot press again, workbench will be down. The mechanism has to work super reliably, and unfortunately, it's not quite doing it every time. Let's see if I can improve that. When going really slow, the clicker seems to get caught on some edge here, which causes it to not rotate enough to properly engage at the next position. Now it does. Let's see if some filing fixes that already. Unfortunately not. The filing helped, but also using more of the assembly to give the pivoting bolt more support improves things quite a lot. but there's still this sometimes. So I very slightly changed the shape. I wanted to work straight off the laser and don't have to file every part. But this now looks promising.
Let's get this updated shape into an actual piece.
Get 2 new clickers and the new piece cut. They look identical, even on top of each other, but it's a very subtle difference. And that makes it work smoothly now, straight from the laser. Let's move on. First parts to weld are nuts in these hex-shaped cutouts. On this, the leveling foot will mount.
And these two are for the foot lever.
Then these go together. Two stitch welds inside and outside should be plenty strong. Next comes this piece that has a bit of wiggle. So to position it properly, I made a spacer tube. Hand tight is enough. Now it doesn't move. And in this hole goes the pin for the clicker with some stick out. So together with a washer, it can still spin freely. That's this bracket done for now.
Next is the assembly the wheel attaches to, which I tried to fixture square and flat with another spacer bushing, my workbench and a welding angle.
That should be all square and aligned, ready for tacking. Okay, got it all tacked, nothing moved, that's good. I'm now gonna weld solid pretty much everywhere in here. And just avoid the fillets here so it doesn't collapse and clamp on the bushing. Now it's a solid brick and I can move the bushing by hand. A good sign that nothing moved or warped. Oh, tiny bit of spring back. It collapsed a little bit, but that's okay. There's plenty of tolerance. So let's put it together. Okay, so far so good. Like on the vice stand, in here will be a spring that will keep the wheels in the up position when not in use. One end can hook into this shape cut by the laser.
For the other end, I'm bending a small hook from some welding wire. It fits 2 holes in a bracket and tacking the ends is enough to secure it.
And that works. Nice. Nailed the clearances.
The last component missing is the leveling foot, which is a disc cut from 6mm plates and a bolt that I'm welding on. I just needed to remove the emboss on the bolt heads to make it sit flat, which I could quickly do on the lathe. On the bottom goes a pad printed in solid TPU for grip on the floor.
And there's the first finished retraction wheel assembly, ready to screw on. There are screw hole locations here and here into the leg, and 2 from the bottom. This is the interface for the foot pedal, and I can also already adjust the leveling foot such the wheel in its up position is about 3mm above ground. That's a good starting point, I guess. Now actuating it puts the wheel about 15mm below ground, which, well, will lift the workbench up by about 15mm. I can't really do tests with one assembly because it will work, I'm sure, but I'd much rather have the second one as well and see if the simultaneous actuation with the single foot lever works. And I have to flip the workbench on its side, which I don't want to do that often. So let's quickly get the second assembly made in 20 seconds. There we are, 20 seconds, piece of cake. They're almost identical, except that this has the interface for the foot lever and this has the lever integrated because the foot lever will push on here. And if this doesn't make sense, it will in a minute when it's mounted. So let's get to that. Oh great, put concrete in the workbench. Ugh. Come on, that's what steel safety shoes are used primarily. The mounting worked great as planned, but I am a bit concerned about this flex.
Let's hope that won't be too big of an issue.
Standing again, you can see I can already kind of lift it. So next comes the foot lever, which I'm gonna make from some rectangle tubing. That's convenient.
Made from 3 pieces in this shape, from which this one has the holes for the bolts that I drilled such that I could weld in a bushing that prevents the tubing from collapsing when tightening the bolts. Then I fixtured the parts into shape.
These magically cut angles aren't the best, but I get the angle accuracy from the welding angles, so doesn't matter.
3 careful tacks on the wood bench, making sure I don't burn into it. The rest then, of course, on the welding table.
Not bad. It's not perfect, as you can see from the gap, but that's good enough. Now in this hole goes a tiny little rounded pin. And that will meet with this hole here. That's the foot lever. Later, of course, with a bigger plate to stand on, and lifting the bench already works. And it's super easy. The other wheel gets this bushing installed here, and the foot lever presses on it, which will lower the wheels simultaneously. Awesome!
There is adjustability built in, so I can make sure when the first mechanism is fully engaged, the second one is too, and both engage properly.
It's working! And with my lifting table as temporary wheels on the other side, moving bench. Oh yeah, this will be useful. Well, that's it with the good news. Now the bad news, and there are quite a few. But the main one is flex in the brackets. You see, the foot lever is mounted to the outside, but the wheel is mounted centered. So as I'm pressing, the whole wheel bracket wants to twist like this. You can see it pretty well here. And it also causes this side to rub on the wood. There should actually be a gap. A bit of flex isn't that big of an issue, but when the wheels are not in the ideal position for lifting, which can totally happen, the flex gets so big that the mechanism of this side doesn't engage. That's fully up, but this side didn't move far enough to properly engage, and then just jams. And now this side is up, and this one isn't. That's pretty bad. So the two sides getting out of sync must never happen, and it has to work with the wheels in any possible position. Next problem, the mechanism is still too sensitive for jamming. So when I want to lower the bench and don't do it all the way, this jams here and doesn't flip around all the way down. I really have to move it into the stop, then it works. And the spring is also not strong enough to properly lift the lever every time, so it would end up here, and then the lifting doesn't properly work. You have to go all the way up into the stop for lifting, into the stop for lowering. And that's not good enough. What was I saying?
It will work, I'm sure.
Don't quote me on that. Let's fix those issues.
The first change for fixing the flex is obviously to just add more metal. Not straightforward though, since it had to clear the leveling foot and spring. Then there's also this rounded section, which I hope is gonna work the way I intended. And the other fix is going from 3 to 4mm steel. Next, improving the mechanism shape again to make it less sensitive. Compared to before, lowering the wheels uses much less movement now. And lifting now works when the clicker only rotated back to here.
And here's the working prototype. Just a bit of motion for the lowering movement, and without all the way up again, the lifting movement works as well. By the way, this says V2, but there were several more iterations that were 3D printed or made in different thicknesses. This took some time, but that also solved another issue. Here, the mechanism shape is within the same steel plate as the hinge and the lever. On the other side, this didn't work because the foot lever would have collided, and so I had to move it to the back side. But then with the flex, the two mechanisms could get out of sync, and that's why we're here. But now with less motion necessary, the collision issue is no longer a thing, and I could integrate it into this piece as well. And with that, any flex in the rest of the bracket will no longer prevent the mechanism from working properly or getting out of sync with the first one. In theory. This time it should work. And the last change is switching from cutting with oxygen to cutting with compressed air. That has the benefit of especially cutting the small details cleaner, as you can see here.
It does leave a much rougher edge, which is a problem for my mechanism that relies on parts sliding. I mean, just listen. And at first it didn't seem to work, but the parts only had to wear in a bit and grind each other smooth. Basically playing with it for a little while. Big relief when that worked.
That should fix all the issues, so let's get the new parts made and weld it up. Excellent fidget toy. If I'd known how much sheet metal fabrication capability would have changed my approach to projects, I would have done so much sooner. And with this video sponsor, JLC CNC, that I already worked with in the past, I could have, and you can too. They are your trusted CNC machining partner, offering fast, affordable and high precision parts for everyone. Maker, engineer or business, no matter the quantity, starting at just $1. And not only sheet metal, but also CNC machining, 3D printing, PCB making and more, all in-house. In the past, they already made many parts for my oscillating belt sander, which were all spot on and delivered in just 1 week. For your next project that's missing the necessary fabrication capabilities, use the link in the description and get the parts made by JLC CNC, starting at just $1 and get $123 in coupons as a new user. During all this talking, I got the welding finished.
This rounded section I wanted to make from some round tubing. Well, a small piece of it.
Next, I need a 120-degree section of the tube, but doing that with the grinder is a bad idea, since the tube will most likely collapse, clamp on the disc, and then bad things can happen. So I'm trying doing that with a laser.
Got a guide installed and a cutting nozzle with compressed air.
Hard to see on camera, but that cut through. Now rotating to the next line. That's cool. Next setup is in the vise with the previous part as the guide and a metal plate to laser into.
And well, that camera angle killed my lens protection. At least the parts came out good and fit.
I had to cut these 2 notches in, so I'm later still able to assemble it, but that now works and I can weld it on too. There we are, and in direct comparison, this first version looks like a joke. Just look at the amount of flex I can do by hand.
Not happening here.
But it quickly showed all the issues with my design, so no loss, and it led to this, so let's get it assembled, mounted and tested. Alright, no more flex or greatly reduced. Now let's try this wheel in the worst position. Works fine, mechanisms stay synced. Let's do both in the worst position. No issue. Let's try them like this, if they want to stay. No problem. Nice. That's now working reliably. But there's still problems to solve, especially access and clearance when mounting to the legs. That was a nightmare.
And we are especially not talking about this.
Oh no. So I'm gonna fix those when building the exact same thing again for the other side, but mirrored. And to save some time, I can just take the first prototype, snap, and be done. Awesome. Now I just gotta do that again.
The mounting axis is fixed and I can now reach all the screw holes. Installing the leveling foot got a bit simpler, and especially mounting the wheel. Without this being a slot, there's no way to install the bolt. Don't ask how I did that before. Then mounting and adjusting the foot lever is quite a bit simpler with the bench flipped over and no load on the wheels.
And there, it's mobile on its own. Oh yeah.
The leveling feet still needed adjustment, which is pretty easy when you can just lift them up.
Now no more rubbing on the floor, just gliding. Awesome. Now let's position it again, right about here. Isn't this great? With the concept now working, I can start polishing it and make it actually nice to use. Because the biggest problem is still the parts rubbing against each other, as you can clearly see from these scratch marks. In my 3D model, there's of course clearance for that, but reality provides you with weld distortion and flex, so there needs to be a better solution than just hopes and dreams. In this case, at least, it's simple. Something that glides along the leg and keeps the lever at a minimum distance.
It's like a small leveling foot, but with a gliding surface. I quickly cut out the parts, toned down a bolt head to sit perpendicular in the little plate, and once welded, added a 3D printed low friction pad, and it will glide along the steel plate mounted to the leg. Then in the lever, I drilled and tapped a threaded hole, so there's some adjustability and possibility to lock it.
Parts are rubbing. And no more rubbing. And with that working, I can make the foot pedal plate, where I'm basically copying the one I made for the vice stand.
It has a grippy texture, which I made by first scoring some grooves into the plate, which guide the welding wire, and then I filled every groove with a bead. To counteract the warping from that, I did the same on the other side, but ground it flush again afterwards.
I'm still working on my stack diamonds for filling small gaps, like in this case, the round to flat transition. And now, this is great.
A sturdy workbench, movable in seconds, and ready to use elsewhere. Let's see what my colleagues think. No emotional outburst, fair. On first glance, they are just wheels, but they inspected them closely and liked them. And I could also test if the wheels are able to lift some weight. Well, yes. Let's get them out of the shop again.
This is so nice, quick and comfortable to use that just because of that, it will get used. And on top, it's pretty compact and not in the way. But if you look down, we're just about halfway through the video. I want more, because there's still a fundamental issue. This wheel system is very custom built and only works with this workbench with these legs. And when I now want to install this system on other equipment, I have to start over every single time. That's not gonna happen. I want a more standardized solution that really just replaces the current wheels with the retracting ones. Works with any size workbench or cabinet, and the biggest one only has a single foot lever. It's gonna be hard, but I've already learned quite a bit from the workbench wheels. A single foot lever being on the side is okay, that works. And for the two wheels, I can reuse the whole concept, because here, that won't bother anyone and leaves access to the front. The difficult part is how to make the other two wheels move and lift when the force from the foot lever is on the other side. I could connect the left and right wheel with some stiff steel tubing to make them move together, but that doesn't work for different sized cabinets, so the opposite of standardizing. The problem to solve is transmitting a force from one side over a variable distance to another side. From the possible concepts of rotating, pushing, or pulling, no doubt pulling has the biggest potential here. Mainly because it's very stiff and could be built from a steel cable or a threaded rod, which are both adjustable, and on top easy to get, light and cheap.
But besides that, there are some more requirements.
All the mechanism motion has to happen underneath, basically in the space currently occupied by the wheels, plus the side for the lever. Easier access to the leveling feet. Here it's quite hard now. And again, easier mounting screw access.
So we basically again have a fixed bracket with a leveling foot and a tilting bracket. But now there's a small lever within the fixed bracket that the wheel bracket pushes against as it tilts down. At the other end of this lever, the threaded rod can be mounted, which then connects to the wheel on the other side. So this wheel tilts, pushes on the small lever, and it pulls on the other wheel, tilting it down as well. And the same mirrored on the other side. All nice and easy on the computer, so let's get it built and see what surprises we have to deal with. For deburring, I had the idea of using a switchable magnet to hold the small pieces. That works excellent, especially for the tiny parts. The rest is all the same as before. Ready for welding, but for some reason my gut instinct told me
I should dry assemble this. Huh, glad I got that before welding.
good call. I then fiddled with it some more to check other clearances and came to the conclusion
I have to remake every single part. At least the laser is fast.
and so I did.
Once again, the parts look identical, but every part is slightly different.
I also went to a small side project for cutting these round sections. So far it was too slow and not accurate. This little jig I clamp onto the tubing where it provides a perfectly straight guide. I engraved 90-degree marks into it to align it for the next cut, and like this I could quickly make the 4 cuts and afterwards cut to length. And there I got 3 accurate and identical pieces and 1 offcut with a tube weld seam.
There it's welded up, pivoting and working. Compared to my first approach here, this is better in every regard. It's overall more compact, using less height. The hinge point and wheel are closer together, which means more leverage for lifting, while the wheel is only slightly smaller, and the leveling foot is now easy to reach.
Welding got easier, especially reaching all welding spots, and except for the foot nut, I could ditch all other nut welding, and since it's overall smaller and more interconnected, I was confident enough to go back to 3mm thickness.
And a big improvement was to get rid of custom fabricated parts. Here I had to make the threaded pin, the hooks for the springs, and a custom spacer washer I didn't even show.
Now the springs can just hook into the laser cut parts, are positioned better and more effective.
Still a problem here.
And the clicker mounts with an off-the-shelf shoulder bolt, a standardized part. You will see more standardized parts throughout the build, also the wheels themselves, and I get all of them from Gantt Norm.
Their parts catalog is huge. They offer 3D models for all of them and almost ship worldwide. Check them out in the video description. Next comes the 90-degree linkage lever that will pivot inside the foot bracket here.
And it's made from a double layer of parts with pin and bushing.
It now mounts to the foot bracket with this bolt, with the nut on top, into this threaded part up here, and then countered with the nut. That should be a strong linkage capable of handling the lifting forces. And this bolt going through the back here is what interacts with the linkage. On here goes one of these clevis forks with snap-on pin, and that's where the threaded rod can mount to transfer the force to the next wheel. So as I'm pushing down on this wheel with my foot, the threaded rod can pull on the next wheel. But now to see if all these improvements and this whole glorious concept actually work, I have to build the remaining 3 wheels.
Okay, let's put this down and pause for a second. Let's try to copy it by drawing a rectangle around it, copy paste and put this here. Another copy and put it there, and another copy and put it there. Good. Now right click, make it real. Looks good. And play.
Oh, sweet. And with the wheel and leveling foot mounted, this is exactly the assembly I envisioned to replace the current wheels with.
So now, let's get this cabinet cleared, the old wheels removed, and the new ones mounted.
The mounting screw axis now is here, here, next to the leveling foot here, and one here. That can also be reached from the top. I planned with hex set screws like this, just smaller. Unfortunately, the right ones didn't arrive in time, but all the access holes are sized to nicely clear the matching socket. Looking at how the screw engagement is distributed across the bracket, that should have a good bite in the wood. Mounted and every single one is working. Also looks like the clearances worked out too, so everything happens underneath the base. And I can roughly set the leveling foot height again about 3mm below the wheel. Rolling works, and it can support my weight. So next, the lifting mechanism on the side, which as mentioned will be similar to the one on the workbench, except that at this time is a piece to screw on instead of being integrated. The foot lever is also similar, but instead of now marking and drilling the interface holes manually, I laser cut 2 spacer parts that are very easy to weld on straight and then perfectly locate the holes for me.
Once drilled, I counterbore from the other side so a bolt head fits through, which at the same time eliminates the need for the short tubes I welded in before. The pin stayed, so alignment and installing the first bolt is simpler.
And working. Oh, compared to the workbench, the foot lever is shorter and lighter, but those springs are so much better.
And then the pin for the second wheel.
Much better than before.
To prevent the parts from rubbing against each other on this design, I made this 3D printed ramp that guides the tube at the very end. Much simpler, and I only had to make sure the foot lever plate didn't protrude the side of the tubing.
So far, this is the same as before, and I was sure it would work again. And now we get into the exciting unknown stuff with the other 2 wheels. Threaded rod will screw into the clevis fork. The other end will mount at the next wheel to this bolt with this eye hook. It's lead threaded, so with one of these adjusters that has threads in both ends, one left, one right, I can adjust the length. And this is off-the-shelf hardware for tensioning steel cables. Starting the adjusters simultaneously. Let's see. Oh yeah, they work simultaneously. Awesome. But the length isn't quite right yet. Yeah, this needs to be tighter. Okay, a little bit tight now. Now it's working fine. That is great. Let's do the other side and see if it also can lift. Oh yeah, all 4 working in unison with one lever. Before flipping over, let's try a little bit of load. That's okay. Here it binds. Not good. So let's adjust that a bit tighter. Okay, let's try on the ground, see what happens. Solid on 4 feet. All wheels are up. Oh yeah. And all wheels are down. A bit light at the moment, but it works. Unfortunately, I had one oversight because there is collision when the wheels are up. So when I lift, roll around, and then this wheel ends up in this position when lowering, it gets caught up on the rod, which doesn't seem good. However, it doesn't seem to matter. Phew.
So now let's add weight. The motor is about 20 kilograms.
All wheels are up. Nothing seems to fail. That was a bad sound. With more load, this one didn't lower, so more adjustment. Next try with more load. All working. All working. Now I moved every wheel to the worst possible position for lifting. This won't happen in reality because they really want to rotate to the best possible position. Still, let's see. Oh, a lot harder to lift. But it works.
So now let's add the machine, which is another 20 to 30 kilograms.
It works. Nice. And it's down, making angry noises. Up and down. Well, you might ask, aren't caster wheels with brakes the exact same thing, but way simpler? Well, kind of, except they suck at being stable. When using equipment, stability comes first, rolling second. So I think this is an amazing concept, but very hard to execute without loads of equipment. So I would really like to make this into a product. Would that be useful for your own workshop and garage? I mean, full-time solid feet for using the equipment, but then quick foot-operated wheels for moving and storing. Kind of the ideal solution for small and efficient spaces. Unfortunately, this first prototype is far from a finished product. So many new problems and problems I thought were fixed appeared in new ways. It proved the concept overall, but isn't reliable enough. So yeah, in total, it's a fail, but that's a good thing. Designing, building and testing these parts, I learned so much so quickly. Nothing else could have shown me the weaknesses of my design quicker and better than failure. Never be afraid of failing, otherwise you will never know what can be improved. I'm also so thankful for xTool giving me this laser. Other sponsors are sometimes difficult to integrate into the project, but here it's just easy. I mean, you saw how it just spits out and welds good parts with minimal effort. I had retracting wheels in mind for years, and this machine finally gave me the capability to seriously attempt it. For quick prototyping and production, especially if you're a business, pick one of these lasers up. It's an investment, but you won't regret it. And of course, with my link in the description, you will help me at the same time. So thank you. Pretty much everything about these retracting wheels needs to go back to the drawing board, but for the workbench wheels, I had an idea to also make them work with only one foot lever. Threaded rod across the bottom obviously doesn't work because I want this to be free so I can roll my chair or other stuff under. But the other solution was steel cable, and I could run that up, across and down to connect both wheel pairs.
This requires making a few additional parts, mainly pulleys. So I had some fun at the lathe, turning them from some aluminum stock. Then I heated them up to expand the hole and fit the bearing. Next were a few 2mm laser parts that would house the pulleys.
The steel cable mounts centered to the foot lever here. And then the first pulley goes up here centered where it makes the first turn. And the next pulley is centered on the other side for the second turn.
Tabletop comes off. Then I drilled a big hole because the pulleys need to be inset a little bit. And then I routed a slot for the cable to pass through.
I got the steel cable with a pressed-on threaded end, a length adjuster, and then again one of these forks. And that attaches center to the foot lever with this piece. Center is basically where also this pin is, right here. Okay, so steel cable is attached and can run over the pulleys and slots to the other side. And of course, when I now press the lever, that pulls on the cable. And to now make the pulling push on this lever, I'm going to weld on another piece to the lever here and use another pulley so I can attach the cable there. This seems like a random placement, but to make this work, the distance from here to the pivot has to be the same as from the center to the pivot. And this angle is just so when it's down, it's vertical.
The third pulley mounts to this bar and a bar to the side.
With it roughly positioned, you can see the cable makes about a right angle with the lever, which is good, so I can cut it to length and mount the other fork on this end. Next is tensioning the cable so both sides are properly synced, which is easiest in the up position. Okay, it already works. Awesome. Okay, and lowering. Well, here we go. This is so good.
The tabletop goes back on, and with the additional weight, it is still
working. At least partial success. I'll take it. I would have really liked to bring these retracting wheels to open source this year so you could try them out for yourself and see and feel how they work. Unfortunately, they are not ready for that kind of testing, but I'm already working on the next design. Nonetheless, you should come to OpenSauce. It's the big maker event of the year from July 17th to 19th in San Francisco again. I'll be there on stage with these folks again, and we can meet in person around the event venue, where you will also see incredible stuff from over 500 exhibits. I've got 2 general admission tickets this year to give away, so if you want to come, leave a comment containing OpenSauce. I will then draw 2 winners, contact you, so the tickets can be issued.